Good morning. I am Prabavathy, Assistant Professor of Mathematics, A.D.M College for Men, Nagapattinam. Today, I am going to discuss about the topic number theory. Number theory is a branch of mathematics which is primarily devoted to the integers and integer valued functions. The famous mathematician Gauss said, mathematics is the queen of science and number theory is the queen of mathematics. Positive integers are classified into two sets. One is prime numbers and another one is composite numbers. First, we will see definition of prime numbers. A prime number is a positive integer that has only two positive integer factors, 1 and itself. Example, 29, 13, 31, etc. They are prime numbers because the only factors of 29 and 31 are 1 and itself. Next, twin primes. If P is a prime and P plus 2 is also prime, then they are called twin primes. For example, 3 and 5, 11 and 13 are twin primes. Next, if two adjacent prime integers are prime numbers, then they are called CMC twins. 2 and 3 are the only CMC twin primes. Next, we will see composite number. A composite number is a positive integer which is not a prime number. For example, let us see number 36. Its divisors are 1, 2, 3, 4, 6, 9, 12, 18, 36. Because it has more than two factors, it is known as composite number. Now, we will see how to find the prime numbers from the list of integers. The famous mathematician Eratosthenes found a method called sieve to find out a prime number from the given list of natural number. Let us see an example. Let us take a natural number 100. First we should write down the number 1 to 100 and first see the number 1. It is not a prime number and neither composite number. So we move to the next number which is 2. It is a only even prime number. So we have to circle it and cross out all the multiples of 2. Then we go to the next number which is 3, which is a prime number. But it is not a composite number. So we should circle it and cross out all the multiples of 3. We have to proceed like this. We proceed like this. We definitely get a list of prime numbers from 1 to 100. So prime number is a major part in the number theory. So Euler tried and proved that the number of primes is infinite. We can also easily prove that. For example, if we assume that number of primes is finite, let us take P1, P2, P3 and so on, Pn is the only prime numbers. But we can construct another number by taking capital P is equal to 1 plus P1 into P2 and so on, Pn. Then we can observe that P is not divisible by any of the prime numbers P1, P2 and so on, Pn. So it may be a prime number or it may be a composite number. If it is a prime number, then we are through because capital P is a prime number which is not in the list P1, P2 and so on, Pn. Suppose if it is a composite number, then it should have a prime divisor which is not in the list. So therefore, anyway we cannot conclude that prime number list is finite. So we can find another biggest prime number from the list of prime numbers. And also, there is a result that the number of primes is countable. That means that we can arrange the prime numbers in an order. For example, 2, next number 3, 5 and so on. And we see a result that is the product of any r consecutive integers is divisible by r factorial. Let us take r consecutive integers, say n plus 1, n plus 2 and so on, n plus r. Let us take the number capital A which is n product of n plus 1, n plus 2 and so on, n plus r divided by r factorial. We can multiply and divide it by n factorial in the term and we can see that this capital A is nothing but the selection of n plus r things taking r at a time. So it should be an integer because selection is an integer. So therefore, the product of r consecutive integer is divisible by r factorial. Now we will see a positional representation of an integer. For example, we will take a number 7354, that is 7354. It can be written as 7000 plus 300 plus 50 plus 4. But in 7000 there are 10 power 3. So 7000 can be written as 7 into 10 power 3 plus 5 into 10 power 2 plus 3 into 10 power 1 plus 4 into 10 power 0. From this example, we can see that any integer can be represented as a positional representation as AA is equal to AN into 10 power n minus 1 plus AN minus 1 into 10 power n minus 2 and so on plus A naught. So, from this representation, we can conclude a result that an integer is divisible by 9 if and only if sum of the digits is divisible by 9. For example, we have taken an example that is 7354. First, we should add the number 7 plus 3 plus 5 plus 4. It is 10 plus 9, that is 19. But 19, we can furthermore, we have to add it. So, 1 plus 9 is 10. But 10 is not divisible by 9. So, we can conclude like that any number divisible by 9 only if the sum of the digits is divisible by 9. Thank you.